Hey everyone, today we're going to take a look at solving equations using algebra tiles on an equation mat, then recording our answer and our steps in a table just to show what we did. And we'll also at the end see how we can check our answer. It's my first time doing this with the tiles and the mats on my computer here, so bear with me if the video is a little sketchy, but I think you'll get the idea. So let's start with this equation down here that says x plus -4 plus 3x equals 2x minus 1 plus 3. The first thing I always do is I start by recording my original equation in my table. So if you're doing this with me, I'd like you to record the same thing on your table, minus 1 plus 3, and I can either put original equation or given. That's what we're starting with. And remember, this solid line down the middle here is representing your equal sign. It separates mat A from mat B, or it separates the left side of your equation from the right side of the equation. All right, second thing we need to do then is build our equation. So I've got x plus -4 plus 3x and on mat B I've got 2x minus 1 plus 3. All right, we've got everything built. I kind of just always want to go back and double check, make sure I have it built correctly, and it looks like I've got x plus -4 plus 3x equals 2x minus 1 plus 3. All right, I've got it built correctly, so now I can move forward. When I look at this, there's a couple different things you could do. Some people might look at this and say, I would see I have 2 x's on each side that could be removed. Okay, so one person might decide they want to take away this 2x and take away that 2x from both sides, and that's a perfectly fine legal move. Another person might look at this and say, oh, I see a 0 pair right here. I want to take that off my mat. That's a perfectly legal move. So there's not really just one way to start it. All right, so keep that in mind as we work today, that the way I'm showing, you might have another way that works and gets you to the same solution. So I don't want that part to be confusing to you. All right, so I think what I'm going to do first here, just because kind of how I think, I like to take off my 0 pairs first, just to kind of work with fewer tiles. So I took away that +1 and -1 from mat B. I'm going to write under my explain what I did. I made zeros or took away zeros. You could say combine like terms. That's mathematically speaking what we did. We combined our unit tiles from mat B. And so what I'm left with on mat B now is I have 2x plus 2. And on mat A, I'm actually going to combine my terms here on mat A also. I didn't take anything off the mat, but what I did is I kind of just pushed my x's together to show that I'm grouping all my x's. And that's going to look like 4x plus -4 on mat A. So I took that x and combined it with the 3x to get 4x. All right, now I'm looking at this saying, okay, I know my end goal is to get my x's positive and all on one side of the mat. And then everything else has to be on the other side. So you're thinking to yourself, what can I do to get all my x's together on one side and have them positive? Because right now I've got 2 x's over here and 4 x's over here, and we can't end like that. So I see pretty easily I can take away 2x from both sides, right? Remember, anything that shows up on both mats can be taken away. Okay, so what did I just do? I removed 2x, or subtracted 2x from both sides. Okay, so what am I left with on mat B? I have 2x plus -4, or 2x minus 4. And now I've just got 2 left on mat B, so we're getting closer. We've got our x's together on one side, and now we need to get rid of all these negatives here. We want to get this on the other side of the mat so our x's are alone. So I think to myself again, what can I do? Oops. what can I do here that's going to get rid of this negative 4? Or what can I do to make that cancel out? Well, I know if I add the opposite, it's going to turn that into 4 separate 0 pairs. So if I add 4 to this negative 4, that's going to help me cancel them out. But I can't just do it to one side. That's one of the most important things when you're solving equations is whatever you're going to add or subtract on one side, you must do to the other side. So I added 4 to both sides, and I'm going to say make zeros right away because I'm going to pull these off. And then I'm going to record what's left on mat A. After I did that, I have 2x, and on mat B, I have 6. All right, so now at this point, we don't want to know what 2x is, we just want to know what x is. So I need to figure out what do I need to divide this by to just get x. Well, I have 2 x's, so I need to divide by 2. If I divide the left side by 2, though, I have to divide the right side by 2. So I'm splitting the whole thing basically into 2 groups. When you look at this, you see that when we divide both sides by 2, we're left with x equals 3, right? Because 1x is equal to 3. Kind of the rule of thumb here is whatever you're multiplying your x by is what you'll be dividing by as your last step. Okay, so I have x equals 3. Now, let's see if I can do my check here. I don't know how this will work on the computer. It's way easier when we can write it out, but let's try it and see. So when I do my check, I'm going to take my original equation, and anytime I see x, I'm going to put in what my answer was. And so I'm just going to here, we said x equals 3, so we're going to check and see if x equals 3. So instead of x, I'm going to put 3 plus negative 4 plus 3 times 3 this time equals 2 times, instead of x, I'm putting in my 3 minus 1 plus 3. So we're saying x is 3, so we're putting it in for x and then seeing if the left side of our equation is in fact equal to the right side of our equation. And so I'm looking at the left here and following the order of operations. I know that I need to do my multiplication first, so I'm just going to bring down 3 plus negative 4. Now I'm going to add 3 times 3, which is 9, and that's equal to 6 minus 1 plus 3. Did my multiplication there too and just brought it down. Again, this is so much easier to see when we can write it. And now I'm just going to add 3 plus negative 4 is negative 1. Negative 1 plus 9 is 8. And I'm wondering if that equals what we have on the other side of the equation. We have 6 minus 1 is 5, and 5 plus 3 is 8. So now I see that 8 equals 8, which means our solution checks. So the answer of x equals 3 is correct. Let's try another one here. This time we'll go a little bit faster through it. So the equation I'm starting with is 3 times the quantity 4 plus x equals x plus 6. So let's build that. Now the parentheses in this one matter a lot. Okay, you have 4 plus x in parentheses, and then on the outside you have times 3. So I'm basically saying I've got 4 plus x. Let me just drag this here. Okay, so there's 4 plus x, and the 3 on the outside means I've got that 3 times. I've got 3 groups of it. So I've got 4 plus x 3 times. So I need to build that same thing 3 times. There's 4 plus x, and here's 4 plus x. Takes a little bit. All right, so I've got 3 groups of 4 plus x, and then on mat B I've got x plus 6. All right, so one thing I'm going to do that sometimes gets overlooked when I'm recording it on a table is I need to simplify this mat A where it says 3 times 4 plus x. I'm going to simplify that. I need to combine my terms here, and in order to do that I need to use the distributive property to figure out how many x's I have and how many units I have. So what that's going to look like on the mat is I'm going to push my x's together, and then I can kind of keep all my unit tiles grouped together, and I see that now instead of 3 groups of 4 plus x, I've got 3x plus 12, or 12, I'll keep consistent here, plus 3x. That 3 times 4 is 12, and 3 times x is 3x. Alright, I didn't do anything different to mat B. I'm just going to leave that as x plus 6. And I can say distributive properties what helped me do that. Okay, so now I want to get my x's alone on one side and my unit tiles on the other, and I think this one I can just pull x off both sides right away because I know if it shows up on both sides I can, oops, that was a positive, I can take it away. So what did I do? I removed x from both sides, and I'm left with 12 plus 2x, and on the right I just have 6. Okay, I've got a lot of unit tiles on both mats that can be taken away. I see 1, 2, 3, 4, 5, 6 on mat B, and I have 6 that I can remove on mat A, and since I'm taking the same thing off both mats, that is a legal move. So I've got 1, 2, 3, 4, 5, and 6. So I stop and say, okay, what did I just do on my mat? I removed 6 from both. Okay, and then I record what I have left. Now I don't have 12 anymore. I've got 6 plus 2x. And oh, I've got nothing left on mat B, so I just put 0 there. So my equation as it stands right now is 6 plus 2x equals 0. All right, we've got our x's positive on one side, so keep them where they are. We're done with those, but let's look at how we can get rid of these unit tiles because our x needs to be alone. So I've got 6 positives here. I could just add 6 negatives. 3, 4, 5, and 6. And if I add it to the left, I have to add it over here to the right. You guys will learn a much faster way to do this in just a couple days here that I think you'll like much better than having to drag all these tiles over. But let's just keep going with this one here. So I'm now canceling out my 0 pairs on mat A. I had 6 positives and 6 negatives, and those cancel out. So we added -6 to both sides, and now over here I'm left with 2x equals -6, and my final step, divide by 2 so that I can find out what 1x is. So if I split that into 2 groups, then I have to also split mat A into 2 groups, and I see that x is equal to, oops, -3. Alright, and then we can substitute that back into check. I'm just going to walk through it verbally here. So I have 4 plus -3, which is 1. 1 times 3 is 3. Okay, so mat A would have 3 on it. Mat B, I'd put in -3 plus 6, which is 3. 3 equals 3, so mat A equals mat B, and our answer checks. So we just got our solution. X equals -3.